In geometry, a golden spiral is a logarithmic spiral whose growth factor is I, the golden ratio. That is, a golden spiral gets wider by a factor of I for every quarter turn it makes. Formula: the polar equation for a golden spiral is the same as for other logarithmic spirals, but with a special value of the growth factor b. Or, with e being the base of natural logarithms, a being an arbitrary positive real constant, and b such that when I is a right angle. Therefore, b is given by. The numerical value of b depends on whether the right angle is measured as 90 degrees or as radians. And since the angle can be in either direction, it is easiest to write the formula for the absolute value of for I in degrees. For I in radians a €/2122225. An alternate formula for a logarithmic and golden spiral is where the constant c is given by, which for the golden spiral gives c values of if I is measured in degrees, and a €/2122224 if I is measured in radians. Approximations of the golden spiral. There are several similar spirals that approximate, but do not exactly equal, a golden spiral. These are often confused with the golden spiral. For example, a golden spiral can be approximated by first starting with a rectangle for which the ratio between its length and width is the golden ratio. This rectangle can then be partitioned into a square and a similar rectangle, and the rectangle can then be split in the same way. After continuing this process for an arbitrary amount of steps, the result will be an almost complete partitioning of the rectangle into squares. The corners of these squares can be connected by quarter circles. The result, though not a true logarithmic spiral, approximates a golden spiral. Another approximation is a Fibonacci spiral, which is constructed similarly to the above method except that you start with a rectangle partitioned into two squares and then in each step add to the rectangle's longest side a square of the same length. Since the ratio between consecutive Fibonacci numbers approaches the golden ratio as the Fibonacci numbers approach infinity, so too does this spiral get more similar to the previous approximation the more squares are added. Spirals in nature. Approximate logarithmic spirals can occur in nature. Golden spirals are one special case of these logarithmic spirals. A recent in-depth analysis of spirals observed in mouse corneal epithelial cells indicated that they can be characterized by both the golden spiral and a logarithmic spiral governing the M51 galaxy. It is sometimes stated that spiral galaxies and nautilus shells get wider in the pattern of a golden spiral, and hence are related to both I and the Fibonacci series. In truth, spiral galaxies and nautilus shells exhibit logarithmic spiral growth, but at a variety of angles usually distinctly different from that of the golden spiral. This pattern allows the organism to grow without changing shape. See also, golden angle, golden ratio, golden rectangle, logarithmic spiral. References